The problem we're going to do here is pretty simple. It's a pretty straightforward math problem. It says Eric makes a list of items he needs to buy for a party and their costs. Find the total of these items. So we're just going to take these four cost amounts in this table and we're going to add them together. Simple enough. What we're going to do that is specific to algebra, though, is that when we do each one of these operations, whenever we work through the problem one step at a time, we are going to name the property that allows us to do each thing that we're doing. Okay, so let's go ahead and get started. So first of all, the numbers that we're going to add together are 9.75, that's the cost of balloons. We're going to add 1850. Then we're going to add 5325. And then we're going to add 2250. But adding the numbers in this order is needlessly challenging. Adding $9.75 to $18.50 is much harder to do than $9.75 plus $53.25. And the reason for that is adding 75 cents to 25 cents makes a whole dollar. Adding 75 cents to 50 cents does not. So I'm going to rewrite this problem so that the 975 is added to the 5325 first. And then I'm going to add the $2 amounts that end with 50 cents because 50 cents plus 50 cents is also a dollar, so that makes it much easier. So I haven't changed the problem. I've just taken the numbers and moved them around. And the property that allows us to do that is called the commutative property. The commutative property is the property that says you are allowed to move the numbers around. We haven't changed the problem. The amount is still the same. Order doesn't matter in addition. We just shifted them around where it's easier to do. Now, the second problem that I notice is if I start doing order of operations, I'm going to do $9.75 and I'm going to add $53.25 and get a whole dollar amount. And then the next thing I'll do is add it to $18.50. It seems like it would be easier if I added the first two numbers together to get a whole dollar amount, then added the second two numbers together to get a whole dollar amount, and then finally the very last thing I do is add those two whole dollar amounts together. That's just going to make the math easier. Well, how do I say that I want to do the first two together, then the second two together? And the answer is parentheses. So we're going to take this exact same problem, but we're going to put parentheses around each set of these numbers. So the $9.75 plus 53.25 will be in a set of parentheses saying add these together first. Then we're going to add the 1850 and the 2250 together. Again, add these together before you do the two amounts together. Now we haven't moved anything this time. All we've done this time is just group pairs of numbers together. And this is called the associative property because we are associating pairs of numbers together. The associative property says these two numbers are an association, and then the next two numbers are an association. Okay, well, this makes the math much easier because $9.75 plus $53.25 is a whole dollar amount, and the whole dollar amount here is $63. Guess I need my equal signs here. This is $63. The same thing happens with 1850 plus 2250. 18 plus 22 is 40, and then 50 cents plus 50 cents is a dollar, so $41. So what did we do here that allowed us to replace the 9.75 plus 53.25 with 63 and to do the same thing for the second set of parentheses? If you replace some numbers with something else, that is called substitution. We are replacing 9.75 plus 53.25 with 63. That's substitution. And the last thing for us to do is to just add these two together. 63 plus 41. 60 plus 40 is 100. 3 plus 1 is 4. So the final answer is it's going to be $104. And this is also substitution because We have replaced or substituted by removing the 63 plus 41 and replacing it with 104. And so the problem that we did here was very easy. It's very simple math. The thing that we did that is algebraic is that after doing each thing, we justified it. We gave a reason why we are allowed to do each one of these things. We supported our answer.